In this video, let's explore borrowing in Rust, a crucial aspect of its ownership system. Borrowing allows you to use a value without taking ownership of it. This enables multiple parts of your code to access the same data safely. When you borrow a value immutably, you can read the data, but you cannot modify it. You can also borrow a value mutably to allow modifications. However, Rust enforces that only one mutable reference is allowed at a time. Remember these rules. You can have either multiple immutable references or one mutable reference at a time, but not both. These rules help prevent data races and ensure memory safety. That's a quick overview of borrowing in Rust. Stay tuned for more Rust programming tips. In this video, let's explore lifetimes in Rust, a key concept for ensuring memory safety. Lifetimes are a way for Rust to track how long references to data are valid. They help prevent dangling references and ensure that data lives long enough for its references. You can annotate lifetimes using a single quote followed by a name like here's a simple example. Rust uses lifetime elision rules to simplify function signatures. For example, if the function has one input reference, the return type will use that reference's lifetime. If you have references with different lifetimes, Rust can infer the shortest lifetime to ensure safety. That's a quick overview of lifetimes in Rust. Stay tuned for more Rust programming insights. In this video, let's dive into structs in Rust, which are used to create custom data types. A struct is a composite data type that allows you to group related data together. Think of it as a blueprint for creating complex types. You can create instances of a struct by specifying values for its fields. You can access the fields of a struct using dot notation. Rust also supports tuple structs, which are similar to tuples but have a name. You can define methods for structs using impl. This allows you to add functionality related to the struct. That's a quick overview of structs in Rust. Stay tuned for more Rust programming insights. In this video, let's explore enums in Rust, a powerful way to define types that can have multiple variants. Enums, short for enumerations, allow you to define a type by enumerating its possible values. This is useful for representing data that can be one of several options. You can create instances of an enum and match against its variants to handle different cases. Enums can also hold data. This allows you to attach additional information to the variants. When matching enums that hold data, you can destructure the variants to access the contained values. That's a quick overview of enums in Rust. Stay tuned for more Rust programming insights. In this video, let's explore the option enum in Rust, which is used for values that can be either some value or none. The option enum is defined in the Rust standard library and is a powerful way to handle optional values safely. You can create an option by wrapping a value in some or using none for the absence of a value. Pattern matching is often used to handle option values safely. You can use unwrap to get the value inside an option, but be careful. It will panic if the value is none. Alternatively, you can use unwrap underscore or to provide a default value if it's none. You can chain methods like map to transform the value inside an option, and underscore then to chain computations that also return an option. That's a quick overview of the option enum in Rust. Stay tuned for more Rust programming insights. In this video, let's explore the result enum in Rust, a powerful way to handle errors in a safe and expressive manner. The result enum is defined in the Rust standard library and is used for functions that can succeed or fail. You can use result to return either a success value with awk or an error value with error. Pattern matching is commonly used to handle the outcome of a result. You can use unwrap to get the value from awk, but it will panic if it's an error. Alternatively, you can use unwrap or to provide a default value if it's an error. You can chain methods like map to transform the value inside a result, and then to chain computations that also return a result. That's a quick overview of the result enum in Rust. Stay tuned for more Rust programming insights. In this video, let's explore error handling in Rust, a language that encourages handling errors safely and explicitly. Rust uses the result enum to represent operations that can succeed or fail. This makes error handling explicit and prevents unexpected failures. One common way to handle errors is by using pattern matching to process the result. If you're sure a function will succeed, you can use unwrap, but be aware it will panic if there's an error. A safer alternative is expect, which lets you provide a custom error message. To make error handling cleaner, Rust provides the write single quote operator, which automatically returns errors from a function. You can also create custom error types to represent specific kinds of errors in your application. That's a quick look at error handling in Rust. Stay tuned for more Rust programming insights.